Hello, my name is Alan Hawes. I'm Vice President of Technical Staff for Solutions and Software at Cypress Semiconductor. In the last lesson, we did the first half of a Find Me application. First, we created a new PSOC 4 BLE design, and then we configured the BLE component. Recall that I talked about GAP, which is the mechanism by which devices connect, and I talked about GATT, which is the mechanism by which devices exchange data. I also talked about profiles, services, and characteristics. Recall that our Find Me peripheral will have an immediate alert service that contains an alert level characteristic. In this lesson, we will take the Find Me profile that you configured in the first lesson, as well as add a little bit of firmware that is required to make it work on the PSOC 4. You'll remember that we chose the Find Me profile, then gave the device a name and asked for a unique ID. And finally, we asked that the name and the service UUID be included in the advertising packet. One thing that makes BLE a little bit different from other PSOC Creator components is the number of APIs that are needed to support all of the configurations and services. To help you navigate these APIs, we added a browsable help window showing all of them. It's a good way to learn about the component firmware and find the right API for your needs. I recommend you open it every time and refer back to it as you write your C code. At this point, we have a BLE component that is configured and ready to go. First, let's add a pin to the project that we'll use to drive an LED based on the alert level I get from the phone. I would like to have the LED be off when there's no alert, blinking with a mid alert, and solid red with a high alert. I will use one of the TCPWMs to perform this function. Add the TCPWM to your design and configure its period to be 1000 and its compare to be 0. Then add a 1 kHz clock to drive it. Lastly, wire the LED to the line_in output of the TCPWM. A little bit later, we'll write the firmware to implement this blinking pattern. Now you need to assign the LED pin to a real pin on the chip. On the Pioneer kit, the red LED is assigned to port 2, pin 6. The next step is to generate application. This will build all of the APIs required to run your device. The BLE firmware is implemented with event handlers that are scheduled by the stack. An event handler is simply a C function that's called automatically by the stack at the right time. For our application, we will require 2 event handlers. The first handler is the generic stack event handler. It will be called when the stack starts or when it establishes or tears down a connection, as well as many other situations. You can read all about the events that can be triggered by the stack in the BLE component datasheet or in the online API browser. For our application, we will simply start the GAP advertising process after the stack is started, as well as restart the advertising after a disconnection. I will implement this functionality using a switch statement to process the type of event. This may seem to be a bit of an overkill, but as we add more types of events in the future, the switch will be a much more robust implementation. Then I'll set up the event handler for the alert service. The immediate alert service handler is called by the BLE stack when the phone writes into the alert level characteristic. Remember, it can write a 0 for no alert, a 1 for mid alert, or a 2 for the high alert. To implement this functionality, I will change the compare value of the TCPWM. When I want the LED off, I'll set it to 0. When I want it to blink, I'll set it to 500. And when I want it solid, I'll set it to 1000. This will correspond to the no alert, mid alert, and high alert states from the Find Me service. The last step is to build the main function. First, start the BLE stack and register the callbacks. Then start the PWM. Lastly, in the main loop, We just keep telling the stack to process events. To understand the data structures, go back to the API documentation. All right, let's program the kit and see that it works. I've installed the CY Smart app on my phone. You can get this from the Google Play Store for Android or from the Apple App Store for iOS. First, I'll reset the kit and then refresh the screen. CY Smart will give you a list of all the BLE devices that it can see advertising. Here, you can see my device, which I recognize by the name that I gave it in the GAP settings. Our device says it has an immediate alert service. This is because we asked the advertising packet to contain the UUID information. Recall this was settable from the GAP screen in the BLE component customizer. This helps me pick out our device when there's a lot of devices around me. When I select the device, it shows me the Find Me profile. If I swipe the screen, I can also see the GAT database. But selecting the Find Me gives me this little pull down that I can use to send an alert. When I select High or Medium Alert, the red LED blinks appropriately. When I go back to No Alert, the LED turns off. So there you have it, your first BLE application. In the next lessons, I'll add another service to this application. I'll talk more about GAT and GAP and talk about Power. And lastly, I'll show you an example of a custom service. As always, you're welcome to email me at alan_hawes@cypress.com with your comments, suggestions, criticisms, and questions.